Hey folks, so I got enough interest in designing and then seeing designing in the CAD and then programming CAM that I will be making a series of videos instead of just showing all of y'all in person. So hopefully this will help. If you have any questions, obviously let me know. I'm going to start with the first video and draft up a vise design that we can then machine later in lab. So right now I'm just going to work on designing the vise, and then in the next video I will do all the CAM programming. So if you already know how to do the design work in AutoDesk or Fusion 360, don't worry about this video and continue on with the next video where I do all the CAM programming. So to get started, I am going to select, I guess I should go a bit slower with and annotate my steps for this, since this is supposed to be kind of an introduction. So I've opened up a new blank document. This is what it'll generally look like if your screen looks different from mine. That's because down here in display settings you can change the visual styles and graphics. I prefer the darker gray because it's slightly easier than staring at that blank white screen. So I'm going to start by clicking Create Sketch. Then I'm going to select my sketch plane. And so with the blue line we have our Z-axis, with the red line we have our X-axis, and the green line is our Y-axis. Doesn't really matter which one you start on, but I generally, since I know what I have or I'm going to be making and I have the design in my head, I'm going to start on the ZX axis, select that. Right here I'm going to select a 2-point rectangle, click at my origin, drag and click. This has formed a rectangle with 4 right sides. Then I'm going to dimension it. I'm going to be using 2 1/4 by 2 1/4 stock to make this out of. So I'm going to dimension this side at 2 inches and this side at 2 inches. That way I can remove stock to get to where I want it to be. So by holding shift and clicking in the scroll wheel, I can rotate around and see my 2D plane. All my lines are white, so it means it's fully defined. If I have blue lines, then I have something that is undefined. So from here I can finish sketch and then extrude, or just hit the E hotkey, which is going to bring me to the extrude section. From here, in this window, I can select different parameters, but I just want to extrude out a block that is going to be 6 inches long. Type in 6, enter. So we've got our just block of material now. So for this, the next thing I'm going to do is create a second sketch. Now I'm going to select the side of the block, and we're going to cut an opening right here to allow for kind of the throat of our part. To dimension this, I am going to go top to top. That didn't do what I want. Control Z. When I click over here, which is going to bring me exactly square with the face I was working on. Try this again. Alright, I'm going to do 1 inch here. And then for the sides, again, 1 inch. Measure here to here, 1 inch. So that has given me a fully defined box. Again, I'm going to hit E, select that window. I can click the arrow, and since it's a cut, I can drag all the way through, and that will do it. Or in these parameters here, I have distances, profiles, all that. Since I dragged back, it auto went to cut, which is what I want. Just hit OK, and now I've cut out the throat of my vise, or the bed of my vise, depending on how you want to say it. Now I'm going to create another sketch on this end. This is where we're going to create the relief to hold our vise jaw in place. So rather than using a 2-point rectangle this time, I'm going to use the line feature. So I'm going to click here on that line and here. If you're clicking on something that already exists and you see that X forms, it's going to auto stop the line right there, which is what it did. So I'm just going to click on that point again to continue. If I don't click on an X, it'll allow me to continue drawing this line however I want. So I'm going to continue out this way until I've formed a sketch. Now I need to start defining this. I've got a lot of blue lines, and I'm going to start with my constraints. Anytime I can use a constraint over a line, that's going to be better for me, because if I change a number and say this line obviously needs to be parallel for this one, then I would have to measure here, here, put a number, measure here, here, put a number. And then if I have to adjust that later, I have to adjust two numbers. So what I can do is a collinear line. Click here and here to make that collinear. And now, when I define this, I only need one number. So let's say 0.5 on that. I am kind of making this up as I go. I have an idea of what I want in my head, but we'll see when we get there. 0.5. And again, I could do another 0.5 over this way to define this line. Oh, so it's giving me a degree sign rather than a distance. That means one of these lines isn't parallel. I know since I extruded this one, it is parallel. So what I can do is come up here to the horizontal vertical, select that line. Now it is vertical with the axes. All right, now I can go back to my sketch dimension, define that. If your options up here look different than mine, that's because in the drop-down menus there are more constraints, more modifications, more shapes you can do. You can hold over it, and in this drop-down you can choose to pin this to the toolbar and add more or remove others. So I have modified this to kind of my most used options. So if this doesn't show up or one of these doesn't show up, you can always go to the drop down to get that done. All right, so I still got blue lines, which is these ones right here. So obviously when I move this, these aren't the same, so I'm going to use an equal constraint. I'm going to say this, whoops. If you have a line selected, it'll auto-select. Control Z. So make sure you don't have anything selected. Equal. This is always going to be equal to that. So now, when I define the width of this center, it will stay the same. So let's define that width right now. Again, I had that blue line selected, so it auto-selected that. I don't want that. Kind of an annoying feature. I need to figure out how to turn it off. But I'm not an expert in this. This is just what I've learned so far. So I'm going to go with 0.51. That will that 510 thousandths will come into play later. As far as overall height, I am going to select from bottom to the top height. I want it to be just above this surface here, so I am going to go with 1.0625, so that's 1 1/16. And now all our blue lines are gone. We have all our constraints. And again, I'm going to, instead of hitting E, I'm just going to hit Finish Sketch to show you where this is. Again, in the Create section, we can do another sketch, or we can just hit Extrude, and this same pop-up that can be gotten by hitting E will pop up. So I'm going to select my sketch plane. I can put in a number right here, like -6, and it'll cut all the way through, or I could have just grabbed the arrow and dragged. Same thing would have been done. If I go this way, it's going to do a join. This way, it's going to do a cut. And I can change that if I want by manually selecting join. But in this instance, I do want to cut. So now I've cut out a channel. So this relief right here will allow the other jaw to slide and keep it angled. As we go, you'll see what I'm talking about. So, all right, so this is a good bit of our body done. So the next thing we're going to do is put the hole for our screw to go through right here. Now for the dimension on that hole, I am going to need to get the dimension for the all thread we are using. I know the all thread we're going to be using is a 3/8 Acme. I can go look that up if I wanted to. And let's see. I'm going to go to MasterCar. Once I am here, I can go to threaded rods and studs. Let's see. And that's not giving me what I want. So lead screws, Acme lead through screws and nuts. There we go. We will go with, let's see, 3/8 12 Acme. So if we look at product detail here, now that's our Acme screw, 3/8 12. I'm going with a finer thread because it'll give us a little more pressure when we're working on it. And usually they are pretty good with telling us what our tap drill size is. All right, so they're not telling us on that one. Probably because I'm looking in the wrong place. All right, so Acme tap, right hand Acme thread, 3/8 12 is what we're looking for. Product detail, and 0.299. All right, so we need a 0.299 hole. Cool. So that's one way to find the information you need. I think MasterCar is pretty useful with that kind of thing. So I'm going to draw my hole, dimension it, 0.299. I always like to dimension to the tap drill size, not the thread outer diameter, because a lot of times when you give these prints to the machinist, they'll look at that, and if you were going for a 3/8 OD thread size, they'll drill a 3/8 hole because that's what you specified in the print. So instead, I'm going to go with the tap size, and then I'm going to dimension it. So I want this centered. Again, I'm going to click up here to square up. Going to go 1/2 inch, and then center is 1 inch. So everything's white now, so we know we're fully defined. Hit E for extrude, select it, drag our hole. All right, so there is our hole for our threaded rod. This is everything we really need for the base right now. So with this, we can now machine everything we need. So important step I probably should have done earlier. Save. We're going to save it to Josh's stuff. Call this vise base. Save. All right, with that, we have our vise base finished. In the next few videos, I will go over drafting the other parts and also machining the other parts. So if you're interested, check those out. If not, hope you learned something. That is it for this video.